All right, well, you've heard this alluded to earlier in the day. Some of the other presenters mentioned something called the Weight Trait Project, and for those of you that are not involved in the Weight Trait Project, because it wouldn't be fair to count you, how many of you have heard of it before? Okay, so I'm going to rectify that. And there's also some other people in the room that could help rectify that to a larger audience. Hint, hint, nudge, nudge. For those people involved with the press in here. The Weight Trait Project actually began in 2009 and started as an integrated project, and it continues that way today. And you heard Bob Weber mention some of these other larger USDA integrated type projects that include not only a research component, but also an outreach, or what we might call extension component. So a couple of years ago now, the 7 largest beef breed associations in the U.S. were contacted and asked for their involvement in this. And part of that involvement was actually nominating, if you will, seed stock producers in the Northern Plains region to participate. So what those seed stock producers were obligated to do early on, and those of you in the audience are thinking, well, our obligations have gotten a little bit bigger over the past few years, but it's a good thing, okay, because it means more opportunity. What they were obligated to do was collect DNA samples on their 2009 born bull calves, right? And we are then going to use those DNA samples to genotype for a reduced marker panel with the target trait of weaning weight. Weaning weight simply because it was a trait that producers could visualize, okay? It was an early growth trait that they could look at, compare some genomic predictions, and say, hey, these kind of line up with what I'm seeing. Now, in retrospect, weaning weight, perhaps we would have chosen something different, like post-weaning gain, something that didn't have a relatively large maternal component, but that's the trait we chose to utilize. So the partners in this project, you see those 7 breed associations listed on this slide. Marielle Identity, in the first year of the project, was a partner in this as well. And then, of course, you see here in the middle the National Beef Cattle Evaluation Consortium that Bob went through and listed the various activities that they've been engaged in over the years. Also, we have the universities up here, South Dakota State, Kansas State, University of Nebraska and Lincoln, and North Dakota State as well. These are schools that have teaching or seed stock herds, if you will, who also had producer collaborators in their state in this project. So this became a way to engage those academics at those institutions so they understood what the producers in their state were actually involved in. So here's where those producer collaborators reside. The majority of them centered around the Meat Animal Research Center, or at least in Nebraska, but as I said, really spanning over the Northern Plains. And Ben, this was in the first year of the project, wherever Ben is in here. We've added actually 4 additional producers from the state of Missouri that will continue with us as this project progresses. So one impetus for this from an outreach standpoint was technology adoption, right? So regardless of the efficacy of any genomic predictions, we have to get them adopted. And there has to be learning that occurs along with that. We've heard about the benefits of this technology to the commercial sector, and if you'll remember, one of the take-home points I had from my initial talk was that the fundamentals for commercial bull buyers are still in place, right? You pay attention to the EPDs and you look at accuracy. Where this technology, true understanding of the utilization and employment of it needs to occur is up here where seed stock animals are raised in the nucleus or even the multiplier levels, because this is where breeding value gain occurs, right? These are the producers that drive your genetic trends. So these producers, if they employ this technology, need to have a pretty good working understanding of it. So what was done, a reduced marker panel of 384 SNP was developed, again, with the target trait of weaning weight. Half of those SNP, 192, actually were trained using the Mark Cycle 7 population, which is a crossbred or composite population that you heard about earlier in talks from Dr. Keene and Dr. Tallman. The amount of animals that went into that training population were about 3,300 animals, right? So a relatively significant size training population to pick these 192 SNP, which are off of the 50K. The population then that we went in and genotyped and looked at the efficacy of this test were from the Weight Trait Project producer herds. They're 2009 born bull calves, which represented purebred animals in these 7 breeds. These 7 breeds are also represented then in the cycle 7 population. So we were training on composite animals, adjusted phenotypes from composite animals, and then trying to predict in purebred populations, all right? And I picked pictures such that they should all be easily distinguished, all right? So if some of you say my breed doesn't look like that, I did that for a reason. To give you an idea of how these 7 breeds were actually represented in that cycle 7 population, this gives you the average percentage contribution of this breed to the training data set. And here's the 7 breeds that I mentioned that have purebred animals represented in the Weight Trait Project. So the panel actually was a total of 384 SNP. So a reduced panel, 192 came from U.S. Mark Discovery, that cycle 7 population that you've heard discussed. But then that was augmented with another 192 SNP. Roughly half of this came from Identity Panel or Identity SNPs that were Angus-specific, trained for post-weaning gain. The other balance of this 192 were parentage SNPs. So that was another component of this project. As also, we did parentage on some of these animals with these producers. And I think one of the take-home messages or one of the learning points in that first year was actually quite a bit of knowledge about parentage, the benefits of it, and actually there were some problems that arose in assigning parentage which actually contributed to a learning moment. The unfortunate thing in this, though, so we used a reduced panel, and at the time, the platform used for genotyping this was a bit new. As a consequence, there were some growing pains because of that. And so there were some genotyping problems. So after a quality control check, only 255 of these 384 SNPs survived. Of those, 159 were SNP trained for weaning weight. So in this quality control process, we actually lost some of what we thought, at least from discovery, were the most valuable SNP for predicting weaning weight. So the process was actually getting tail hair from the ranch, which this in and of itself was a bit of a learning experience for some, but I think we've surpassed some of those growing pains. But tail hair from the ranch to GeneSeq, where the genotyping was actually done for this reduced panel, and then the calculation of molecular breeding values down here that some of the others have discussed. So the analysis, the correlated trait approach via Catchman, the first described in press probably in 2008. Same process again that the American Angus Association uses in 2 and 3 trait animal models. The problem I mentioned before of the newness of the genotyping platform manifested itself in the variation of call rates or number of missed calls here. So ideally, we would have all 384 SNPs called, right? We would get a genotype for all of them. We wouldn't have missed any or had to cull any in terms of quality control. But in this case, the average call rate was about 85%. So substantially less than what could be considered desirable. And that actually ranged from about 11% all the way up to 100%, right? So good and very, very damn bad, right? But initially, that could be considered as a huge problem and failure of the Weight Trait Project. But as you'll see, it actually came to something quite good. So really the issue was this, an issue of partial information, okay, related to these genotypes. And this is, I don't paint my toenails, but this would be like me at the doctor's office, right? I like food, and so I always like to try to cheat when the doctor makes me get on the scale. The problem is, though, you only get a glimpse onto what you actually weigh. But it's not missing information. It's not 100% missing. There's partial information there. So imagine if we had people do this, they put 1 foot on, 1 foot off, then finally we coaxed them to put both feet on and we got a full weight on them, right? We know what their weight is with 1 foot off. We know what it is with both feet on. So then we can be able to get an idea of how much of the full information this scenario lends itself to. So that, in human speak, is what Steve did. So here I have the 7 breeds, the heritability for weaning weight direct. Are Simmental breeders in the Weight Trait Project in here? You look at that right there. It's been fixed, Dave. Okay. This is heritability of weaning weight direct, the heritability of the molecular breeding value before we accounted for that missing or partial information, and the heritability of the molecular breeding value after. Now, what you'll notice in both cases, we're not at 1, which is people have alluded to earlier. That's what we'd expect the heritability of the molecular breeding value to be. But you can see in general an improvement after we use methodology to account for the partial nature of those genotypes. Here we have the genetic correlation between the molecular breeding value and the trait of interest, which is weaning weight, before we accounted for the partial nature of those genotypes in the analysis and after. Before we accounted, these are genetic correlations, so you square these, you get the proportion of variation explained by that panel. It's between 0 and 8%, roughly. Afterwards, you're between 0 and roughly 14%. So there was an improvement. So I really think that's one take-home thing in terms of development of methodology in the first year, was how do we accommodate the fact that we have missing genotypes, which as we move to sequence data, particularly low-depth sequence data, could be an issue. So that's one thing that the Weight Trait Project has done, is help develop some methodology and will continue to do so. Here, I should say, limousine is missing the after. That's simply because at the time this analysis was done, we weren't able to garner updated information in time. So another part of this, as I mentioned, was the integrated component in terms of education. And so what I asked, and those of you that filled out the surveys now wonder why you did it, and here's why you did it, all right? Because I was curious. We asked them on a 1 to 4 scale, how much knowledge did you gain in these areas? 1 being you didn't teach me anything, 4 meaning you knocked my socks off and taught me a lot. As you would expect from these seed stock producers, we probably didn't do a tremendous amount to educate them in EPDs. They're already very knowledgeable of that. But if we look at things in terms of marker-assisted selection, even things in terms of accuracy improvement with including genomic information to EPD calculations, and just flat terminology we throw around, MVV, GPE, but and companies, MVP, whatever you want to call it. There was a lot of education that occurred there. Behavior change. How likely are you to make changes because of what you learned? 1 says, I'm not going to change anything I do. 5 says, I'm likely to make considerable changes to what I do. You can see some fairly high scores here, including making more informed selection and mating decisions, better educating their commercial clientele, and their general comfort with the terminology that we utilize. And so this is what a fraction of you guys said that you learned through this entire process. So as we look forward with this project, it's not a 1 year or 2 year and done. It's evolving. What we've moved to now, we genotyped calves with a reduced panel for weaning weight. And we've gone back and said, you know what? We genotyped calves with a reduced panel where training occurred in a composite population based on phenotypes. We've already heard about the reasonable expectations of that. We're going to genotype sires now with the 50K chip and go back and look at this. And you've seen some of those results that Mark presented earlier today. The other thing, the addition of those herds from Missouri, the quest there was to do a pilot project actually looking at genotype by environment interactions. The environment in the Northern Plains region is a bit different than the fescue environment in parts of Missouri. Those 2 projects were funded by the University of Nebraska at Lincoln and also considerable financial support was supplied by the Meat Animal Research Center. We're also moving this project into the feed efficiency grant that Bob Weber just got done talking about. So what's going to happen is that these producers have nominated sires that they own to produce crossbred progeny that will go through a grow-safe system and have feed intake data collected and serve in part as a validation population for discovery coming out of that feed efficiency project. So not only do they get to actually have a mini, if you will, progeny test that contribute to validation here. What we'll also do is genotype a number of their females that they've collected for us with the 50K and be able to retrospectively apply a feed efficiency prediction to those and actually follow these females then through production in their herd to look at the relationship between female fertility, if you will, and then also feed efficiency. So this project, as it stands now, has served as a very useful validation, as you heard about the 2000 bull predictions and GPE prediction equations, and it will continue to do so because this project will continue to grow in terms of the number of phenotypes and the number of genotyped animals that we have. So here's a plug for that feed efficiency. You guys don't have any idea how many emails it took to come up with this. And JR, you're in the room. I appreciate the effort you put into that. But to be frank, I started deleting emails after about the first iteration. But it came out well. As that project matures, you can find information about research results here at this website, eBEEF.org. So what I want to impress upon you as well is the fact that the Weight Trait Project has brought together breed associations, seed stock producers, and now as we move into the feed efficiency project, will also include large commercial ranches where these sires are actually going to be used to produce those crossbred calves, plus research and extension personnel. So really it is a collaborative effort to move forward, to validate products, to develop methodology, and to educate. Here's the research team. You have scientists from the Meat Animal Research Center, and then also my colleagues at the University of Nebraska in the Department of Statistics, Kathy Hanford and Steve Catchman, whom you've heard earlier. So the fact I'd also impress upon you is, as this is a pretty vast population in terms of researchers that are trying to tackle a lot of these issues. So with that, I'd answer any questions that you might have about this. Hopefully you have some understanding for what the Weight Trait Project is now, and the fact is you're going to continue to hear more about it as it continues to mature. So one other house cleaning item that I want to mention quickly is that we do have a survey that I would really appreciate if you'd fill out. Tell us how you felt about today's meeting, because these meetings are going to occur on an annual basis, and we really do want your feedback in terms of how you felt about today and what we might have in terms of presentations going into the future.